All right, guys, last lesson of this first module, 3.1.4. And I think this will be a pretty quick and easy one, so just make sure you're paying attention because we're going to go relatively quickly. So we've talked about function notation and f of x and all that kind of stuff. We've graphed some functions, f of x. We've talked about what happens when two functions, f of x and g of x, what happens when they intersect and how to recognize points of intersection. Today we want to talk about domain and range, inputs and outputs, independent with x and dependent variable with y, or f of x. And today we want to talk about evaluating specific points for a function. We'll get a little bit deeper into this after this lesson, so don't focus on this too much, but we'll get into what some of that stuff means later. In this lesson, we're going to explore, finding a specific range given a specific domain or set of inputs. So, for example, we have this domain. We know our inputs are only 1, 2, and 3. Okay, and then we have this function. Remember that this whole side, this f of x thing, it's really just y. Okay, it's just a different notation, a different way of writing. It doesn't mean f times x. It means f of x, and that's just something called function notation. So to evaluate f over the domain 1, 2, 3, we would write the following equations by substituting in each value of the domain x into the function. So f of 1 means you're going to plug in 1 for x, right? We replace, so f of x equals 2x, right? So we're replacing the x with a 1. See what's happening there? And we're going to evaluate that. So f of 1 equals 2, which means that the solution there is 1, 2. Right? That's your point if you were going to graph it. Right? F of 2, we would replace the x with 2, which means we get 4. F of 3, we replace the x with 3, which means we get 2 times 0, which is 6. So my range, and we'll just go ahead and write those points. So again, f of 2 is 4, and f of 3 is 6. So those points are 2, 4, and 3, 6. Okay? So with the brackets, they wrote your range down here, just like they had your domain up here. So they split out the x's and they split apart the y's. When they're just writing domain and range. Okay? Because the domain is just the x's, and range is just the y values. Okay? And then the 3 points are these. Alright? So, move on. Key concepts. Functions can be evaluated at values and variables. That's important. You can plug in variables too. We won't do as much of that today, but I just want you to be aware of it. Substituting the domain values to find your y values. Using an example here to evaluate f of 2, literally replace the x with a 2. And if there's more than one x in the problem, you're going to replace all of them. Like say I had x plus x, or x squared plus x, and I want to find f of 2. I would plug the 2 in both parts. Okay. This is a point, so this again is like x comma y. And remember, f of x and y are basically the same thing. It's just saying, all this really says is that that variable is dependent upon x. It's a function of x, so it's a function based on x. Okay. Common misconceptions, this is the biggest one, thinking that it means f times x. It does not. It is not f times x. Okay, it's f of x. Alright? So, example 1, find the domain for this. So I need f of 1, which means I'm going to do 4 times 1 minus 7. Okay, which is 4 minus 7 is negative 3. F of 2 is 4 times 2 minus 7, which is 1. F of 3 is 4 times 3, which is 12 minus 7, which is 5. And f of 4 is 4 times 4 minus 7, which is 16 minus 7, which is 9. So my range is negative 3, 1, 5, and 9. Not too complicated, not too hard. I don't think we're gonna have much trouble with this lesson. Okay. All right. Evaluate the next one. This again. This is g of 0. So I want to do 3 to the 0 power plus 1. It's not 6, it's 0. All right. And so 3 to the 0 is 1 plus 1 is 2. G of 1 is 3 to the first plus 1, which would be 3 plus 1, which is 4. G to the second is going to be 3 squared plus 1, which is 9 plus 1, which is 10. And then G to the third would be 3 to the third, which is 27, plus 1, which is 28. So on this one, we would have 2, 4, 10, and 28. Okay? Last example here. Raven started an online petition calling for more vegan options in her school cafeteria. So far, the number of signatures has doubled every day. So exponential. She started with 32 on the first day, and then her petition can be modeled by the following function. Evaluate f of 3 and interpret the results in terms of the petition. So, day one, which is actually day 0, because it's your 0 is your initial amount. But after the first day, or on the first day, she had 32. Day 2 is double, right? So that'd be 64. Then day 3, that double, okay, which is 128. And then day 4, okay, which is actually only 3 days after the starting date. So that's why this is f of 3. Okay, then we're going to have 256. Just have to be aware of what it means in the context of the problem. They've already done the work, right? They evaluated 3, they plugged it in for x, and then 2 to the third was 8, and then 8 times 32 is 256. So on day 4, there are 256 signatures. Okay. All right, and we will stop there with your examples. Good luck on it, and we have a quiz on Friday.